Welcome to the second part of our series on quadratics. In this part, we're going to look at factorising quadratic expressions of the form ax squared plus bx plus c, where a, b and c are numbers. In other words, the number in front of x squared need not be 1. It could be anything such as 3, 5 or 12. Now, in this first question, it's quite easy to do in the same way that you've learnt already. Okay, and we know that to get the 3x squared, it can only have come from a pair of brackets that begin with 3x and x, and that is because 3 is a prime number. All right, now we also know that the minus 1 can only come from 1 times minus 1. So the question is it 3x plus 1 times x minus 1, or the other possibility is that it's 3x, the minus 1 goes with the 3x, and the plus 1 goes with the x. It's one of those two. And what we need to do is test the outer and inner terms to see what they get, because we know it's going to work for the 3x squared, and we know it's going to work for the minus 1. But we don't know about the middle term until we test it. Well, 3x times minus 1 is minus 3x plus 1x. That gives me minus 2x. Okay? So that's the right one. The other one would have given me 3x times 1 is 3x minus 1x. That would have given me plus 2x. Okay? So that would have been the wrong one. This is the correct one. Okay, so it's a simple question of having a look, getting the first and last numbers sorted out, and a quick check to see what happens in the middle. Now, it's fine for numbers where they're quite small, and particularly if they're prime numbers and odd numbers. Now, on the second one, we can take it the same way. We just have to do a little bit more work on this one. All right, you'll see why in a moment. So in question 2, okay, we're going to start with recognizing that 5 is a prime number. So it's going to be 5x times something beginning with x. Okay, and that can happen in 4 different ways, as you'll find out in a moment. But let's just look at 2 of them first. Okay, well, the 5 has got to come from 5x times x, and the minus 7 could be minus 1 times plus 7, or it could be from plus 1 times minus 7. Okay, but the other possibilities are that it could come from 5x minus 7 times x plus 1, or it could come from 5x plus 7 times x minus 1. I think you can see that those are the 4 possibilities. They would all give us the minus 7 at the end. They would all give us the 5x squared at the start. But what would they give us in the middle term? That's what we're interested now in checking. So in the first one, we've got 35x minus 1x. Well, that's 34x. Okay, which is clearly not what we want, because we're looking for plus 2x, aren't we? So it's not the first one. The second one is giving us minus 35x plus 1x. So that's giving us minus 34x. Also no good. Now, it'll be one of these two. 5x times 1 is giving us 5x, minus 7x, that's giving us minus 2x. So it's not that one, it must be this one, and I think you can see that it is. because that's minus 5x plus 7x, which is indeed giving us plus 2x, which is what we need to make that in our expression. So the correct factorization of this is that one there. Okay, but you wouldn't necessarily need to write all of those down. You could probably narrow it down quite quickly and get to that fairly quickly. However, this is more of a challenge because look, what could you possibly do to start? You could have 12x times x. You could have 6x times 2x. You could have 4x times 3x. To get the minus 40, that could come from 1 and minus 40, 40 and minus 1. It could come from 20 and minus 2. It could come from 10 and minus 4. Minus 8 times 5, minus 5 times 8. There are so many different possibilities. It could take a long time to find the right one. But there is a method that we're going to use. Okay, we split up the middle term into two, and we do it like this. Okay, the first step is to multiply together the first and last terms. All right, multiply those together and you get negative 480. Okay, you now look for pairs of factors of minus 480 that add together to give 17. Now, there are many of those, and this in itself could take a while, but we will just quickly move to roughly the right place, and you'll see how this works. 2 and 240 make 480. One of them I'll make a minus. Okay, let's try another pair. Let's go for 10 and 48, minus 48. Okay, these are multiplied together. Okay, and I'm looking for a pair that add to give 17. Well, I can see that the one on these are both going to make large negative numbers. So we need to probably be putting the minus sign on the other side. Let's try 15 and 32. Okay, now, okay, I'm cheating slightly because I know they are correct, because I'm looking for a pair of numbers with a difference between them of 17. Then I can deal with the minus sign, you see. Well, if I have 32 and negative 15, if I multiply them together, I do get negative 480. And if I add them together, I get 17. All right. So what I do now is I rewrite the expression here by splitting the middle term up into minus 15x and plus 32x. So it looks like this. 12x squared, okay, minus 15x plus 32x, okay, minus 40. So I've got my original expression, and all I've done is I've split that 17 up into minus 15 and 32 because I discovered that those two numbers multiplied together to give me 17. Sorry, added together to give me 17 and multiplied together to give me minus 480. Okay, now I do a really smart thing. I look at these in pairs. So I take the first pair of these, right, like this, and I say, what do I need to factorize out of that group there? Okay, and it's this. The highest common factor of 12x squared and minus 15x is 3x. Okay. So I do 3x brackets 4x minus 5. So that yellow line factorizes out into 3x times 4x minus 5. Okay. And then I take the other half, if you like, I'll put that in a different colour, this bit here, okay, and I factorise that out, and it will give me plus, now the common factor there, the highest common factor in there is 8 brackets, and that will also give me 4x minus 5. Now if you've done this properly, you'll get 2 identical brackets, okay, and the bits left over. And what we do now is we simply combine the 2 leftover bits to make the other factor. So that is equal to 3x plus 8 multiplied by the other factor, which is 4x minus 5. Okay, now if you were to test that by doing FOIL, you would indeed get this expression here. We'll just do that quickly if you like. So what we've got is 3x times 4x. Well, that does indeed give me 12x squared. Okay, we have our outer term, which is minus 15x. Okay, you can see how it came about because we're going back to this now, you see. Our inner term is plus 32x. Okay, and our last term is 8 times minus 5, which is minus 40. And so when we combine these 2 terms, we go back to our 17x that we started with. So we can see that it works, all right? But it was very difficult to have got those because we wouldn't have known where to start. We wouldn't have known it was 3 and 4. It could have just as easily been 6x and 2x, or another possible starting point. Okay, so that method of splitting the middle term is useful if you've got larger numbers in front of x squared and at the end numbers that are not prime, and particularly numbers that are even as well. It just takes a long time if you try to do it this way. But if it's something like 3 or 5x squared and it's something like 1, 3, 2 at the end, or 7 or 5, it's quite quick, as you saw in examples 1 and 2. All right, okay, that's the end of this session on factorising ax squared plus bx plus c.